Imagine that I have two springs in a series of springs, and later on we're going to put more. But we have two springs which are in a series, as shown in figure. When I deflect this system, it will happen that the total deflection of the system, which is x, is going to be equal to the deflection given by spring 1 plus the deflection given by spring 2. Now, in order to deflect them, I need to input a force towards this direction, and that might be the force of the spring in order to deflect. So the force in order to deflect them is going to be equal to K1x1, which is the force I need to deflect the first spring, but that's also as well the force I need to deflect the second spring. And I will call that the effective force. So it will be equal to the effective constant, which is the combination of both of them, times total deflection. And if I state that x1, the deflection for the first spring, is equal to the force over k1, but also x2 equals the force, which is the force I am inputting, because I am only inputting one force, over k2, then if I plug these two expressions into the first term, well, I may also state that the total x equals the force I am stating over the effective k. I will actually state that f over k effective, which is x equals f over k1, which is x1, plus f over k2, which is x2. And this might actually state, since the forces are the same and I can cancel, that 1 over the total effective k equals 1 over k1 plus 1 over k2. Or more general, the sum of the inverse of the k's will give me the inverse of the effective k. Now, if instead of having a series of springs, I have springs that are being in parallel, if I, for instance, pull or push, whatever you want to state, or move the spring towards the right, well, I will deflect spring 1 in the same way I deflect spring 2. So it means that the x that I am deflecting equals x1, but it's exactly the same as the deflection of x2. And now I have to input two forces, the force to deflect the left spring and the force to deflect the right spring, such that the force will be actually equal to k1x and will be plus k2x, and that will be an effective constant times x I am deflecting, such that if I can cancel terms of x which are exactly the same, I will actually have that the effective constant is going to be equal to k1 plus k2. Or in other words, if the springs are in parallel and I want to get an effective constant of the whole spring, I just sum up the k's. Look between the difference. This is the sum of the k's, and the other one is the inverse sum of the k's will give me the inverse of the constant. This is very similar to what happens when we are adding up capacitances in capacitors, because both systems are actually storing energy. This is storing mechanical energy. Later on in life you will see that a capacitor will be storing electrical energy.